Question 13. An organic compound on qualitative analysis was found to contain carbon, hydrogen, nitrogen and oxygen. 1 gram of it on oxidation with copper oxide and oxygen gave 1.239 gram of carbon dioxide and 0.1269 gram of H2O. 2 gram of the sample was digested with concentrated sulphuric acid and the residue was distilled after the addition of excess solution of sodium hydroxide. The ammonia evolved was absorbed in 50 milliliter of 1 N sulphuric acid. The resulting solution was diluted to 500 milliliter in a measuring flask. 25 milliliter of this solution required 21.8 milliliter of 0.05 N NaOH for complete neutralisation. Calculate the empirical formula of the compound. The given organic compound contains carbon, hydrogen, nitrogen and oxygen. The nitrogen present in the compound is converted to ammonia and is absorbed in 50 ml of 1N sulphuric acid, यानी कि 50 milliequivalents of sulphuric acid. So out of this 50 milliequivalents of sulphuric acid, some of it reacts with ammonia while the rest of it is neutralized with 21.8 milliliter of 0.05 N NaOH. So total amount of sulphuric acid which is present will be 50 milliequivalents and the remaining sulphuric acid or the sulphuric acid in excess will be equal to milliequivalents of NaOH. And when we will subtract the milliequivalents of remaining sulphuric acid from milliequivalents of the total sulphuric acid, we will get the milliequivalents of ammonia. Total milliequivalents of H2SO4 will be equal to volume of H2SO4 into normality of H2SO4 or normality into volume, that is 1 into 50, which is equal to 50 milliequivalents. Now H2SO4 in excess or H2SO4 left after the reaction will be equal to milliequivalents of NaOH, and this is equal to 0.05 into 21.8 milliequivalents. Now these many milliequivalents of H2SO4 are present in 25 milliliter of the solution. Therefore 25 milliliter of the solution contains 0.05 into 21.8 milliequivalents of H2SO4 in excess. Therefore 500 milliliters of the solution will contain 0.05 into 21.8 divided by 25 into 500, and this is equal to 21.8 milliequivalents of H2SO4. Therefore, milliequivalents of H2SO4 used in the reaction will be equal to 50 minus 21.8, which is equal to 28.2 milliequivalents. Now this is also equal to milliequivalents of ammonia, and it is also equal to millimoles of ammonia. Now 1 mole of ammonia contains 1 mole of nitrogen. Now moles of nitrogen in ammonia is equal to moles of ammonia, because 1 mole of ammonia contains 1 mole of nitrogen. So moles of nitrogen is equal to moles of ammonia, which is equal to 28.2 divided by 1000, and this is equal to 0.0282 moles. Millimoles of ammonia is 28.2. Therefore, moles of ammonia or moles of nitrogen in ammonia is 0.0282 moles. Now, this is the moles of nitrogen in 2 gram of the compound. Therefore, moles of nitrogen in 1 gram of the compound will be equal to 0.0282 divided by 2, which is equal to 0.0141 moles. Now moles of carbon in the compound will be equal to moles of carbon dioxide, because 1 mole of carbon dioxide contains 1 mole of carbon. So moles of carbon in the compound. So moles of carbon in the compound will be equal to moles of carbon dioxide, which is equal to weight of carbon dioxide given as 1.239 grams divided by molecular weight of carbon dioxide, that is 44, and this is equal to 0.0281 moles. Similarly, moles of hydrogen is equal to 2 into moles of H2O, because 1 mole of H2O contains 2 moles of hydrogen, and this is equal to 2 into weight of H2O जो कि given है 0.1269 ग्राम, और इसको डिवाइड कर देंगे मॉलिक्यूलर वेट ऑफ H2O से, which is 18. So this is equal to 0.0141 moles. तो moles of hydrogen हो गया 0.0141 moles. अब to find moles of oxygen होगा weight of oxygen divided by atomic weight of oxygen, which is 16. अब weight of oxygen will be equal to weight of the given compound, which is given as 1, minus weight of carbon. Weight of carbon है moles of carbon into atomic weight of carbon जो कि है 12, plus which is equal to weight of hydrogen. Weight of hydrogen होगा moles of hydrogen into atomic weight of hydrogen जो कि है 1, plus weight of nitrogen, which is equal to moles of nitrogen into atomic weight of nitrogen, which is 14. So weight of the compound जो कि 1 ग्राम है, उसमें से sum of the weight of carbon, hydrogen और nitrogen माइनस कर देंगे, and we get the weight of oxygen as 0.4513 ग्राम. तो यहाँ पे weight of oxygen की वैल्यू पुट कर देंगे, that is 0.4513 grams, and moles of oxygen will be equal to 0.0282 moles. अब मोल्स ऑफ नाइट्रोजन, कार्बन, हाइड्रोजन और ऑक्सीजन में लीस्ट नंबर ऑफ मोल्स प्रेजेंट है नाइट्रोजन और हाइड्रोजन के. सो मोल्स ऑफ नाइट्रोजन, कार्बन, हाइड्रोजन और ऑक्सीजन को लीस्ट नंबर ऑफ मोल्स से डिवाइड कर देंगे और हमें मिल जाएगा रेशियो ऑफ कार्बन इज टू हाइड्रोजन इज टू नाइट्रोजन इज टू ऑक्सीजन, जो कि होगा 2:1:1:2. So the empirical formula of the compound will be C2H NO2.